Actual drilling is still the only conclusive step in finding oil. Even today, in new field drilling, only about 1 well in 9 becomes a producer. Costs of drilling a well will average about $77,000, but some wells have cost as much as $1 million. The older cable tool method is still generally used in drilling formations hard enough to stand up well and where low cost rather than speed is the principal consideration. The rotary drilling method, developed since the turn of the century, is now used more extensively. Although more expensive, it is speedier and enables drilling through loose, unconsolidated formations to far greater depths. In drilling to depths of 2 or even 3 miles, the repeated raising, lowering, and handling of the drill pipe to replace the bits is a difficult, time-consuming function. Steel pipe or casing is used to line the well walls and give them strength to prevent caving in of the hole. Cement, pumped around successive strings of casing, seals the holes against leakage of oil, gas, or water. As the drill passes through various types of formations, weight on the drill bit must be suitably adjusted. This retards wandering of the drill from its course and possible buckling or bending from the accumulating weight of added drill pipe. Chemically treated muds are pumped through the hollow drill pipe to cool and lubricate the bit and carry the rock cut away by the drill back to the surface. It also plasters the walls of the hole to help prevent cave-ins. A screening device called a shaker removes the rock particles from the mud, preparing it for reuse. Samples of the cuttings are examined to determine the kind of strata being drilled through. Even the senses of taste and smell are used as an occasional quick test when it is suspected that oil-bearing formations are being approached. Core samples are taken with a special drill bit at some drilling locations. These are sent to field and central laboratories, which test them for porosity, or the volume of small cavities that may contain oil, permeability, or the potential rate of flow through the rock pores, and the oil content of the sample. Still another method of estimating underground conditions is through measurement of electrical resistances at various drilling depths. This process is known as electric logging. During the process of drilling, a special valve at the top of the hole may be closed off in the event of unexpected blowouts. When an oil-bearing formation is reached, the drill is pulled. Heavy muds are used to hold back the flow of oil from natural pressures. Wells are no longer permitted to blow in as dangerous, wasteful gushers. A final string of casing is set. Some wells are shot with explosives, permitting the oil to flow into the well. When the glass-enclosed charges of this perforator are detonated in the hole, powerful jet explosions penetrate the casing and surrounding rock. A small diameter tubing through which the oil will come to the surface is installed. At the surface, a system of valves called a Christmas tree is installed. This controls the flow of oil. Sometimes wells are treated with chemicals or acidized to open up passages in the limestone for the oil to flow through. Other chemicals may be used to stimulate oil flow and prevent water migration to the well. When natural bottom hole pressures are not enough to force the oil to the surface, the well is put on the pump. In many locations, ingenious centralized power systems work a number of well pumps, bringing the oil to the surface and sending it to the storage tanks. In the present-day application of scientific production methods, the industry is wisely trying to conserve reservoir energy by maintaining subsurface pressures. No longer are wells drilled without regard for adequate spacing. The production of individual wells is carefully regulated to prevent waste or depletion of reservoir energy. However, in many fields, reservoir pressures have been lowered to a point where oil does not flow naturally to the wells. In many such locations, natural gas, usually associated with oil production, is first piped to cycling plants where liquid products are extracted. The gas is then pumped into the oil-producing zones, where the pressure helps the oil to flow through the sands and porous rock toward the wells. In other locations, water instead of gas is employed to drive the oil. These are a few of the many ways in which oil is now recovered that would otherwise have been lost forever. Oil production on land has been augmented in recent years through drilling at sea. Oil producers are thus opening vast new production potentials to bring more oil to the nation.